yesterday, we went over left Riemann sums, right Riemann sums, and midpoint Riemann sums. All right, today we're going to talk about the trapezoid approximation method. And the idea with the trapezoid approximation method was if we have some curve, right, so here's our curve, and from some point A to some point B, we want to approximate the area underneath the curve. And suppose we break it up into like 4 rectangles. Then what the trapezoid method does is it basically takes advantage of the imperfections of the left rectangle method, approximation method, and the right rectangular approximation method. And so what these methods are saying is left, we pick our left endpoint. With the right, we pick our right endpoint. For the trapezoid method, we draw a secant line between those two endpoints, and we create a trapezoid. So there's a secant line, secant line. And if you look at that, it looks like the area underneath the area of the 4 trapezoids is a much better approximation than our left Riemann sums and our right Riemann sums. And it turns out that it always will be a better approximation than left Riemann and right Riemann sums. All right, so this is the trapezoid method. So who can tell me what the area of a trapezoid is, just in general? What's the formula for the area of a trapezoid? What is it, Max? Go ahead. 1/2 times?
Base. B1 plus B2.
Yeah, so that's the average of the bases times the height. So, the way I always thought of it is if we have some trapezoid right there, take the midpoint of this length, that's averaging the lengths, and you draw this, now we have a blue rectangle, and the average of the blue rectangle, or the area of the blue rectangle is the area of the trapezoid, because the idea is that this amount is the same as that amount, so you're compensating. That's where the formula comes from. You're just averaging bases. Okay? So let's call these points, let's call this x1, y1, x2, y2. This point will be x3, y3. This point, x4, y4. And this point, x5, y5. Alright, so what we're going to do is I'm going to write out the formula for the trapezoid method, and then something interesting is going to happen after I do some manipulations. So I want us to notice this. So here it goes. The area by trapezoid method, the first trapezoid. Now, these trapezoids, we sort of have to turn our heads and look at them sideways. Because what I'm saying is, this distance is our height. And we're going to go ahead and assume that I split up my intervals evenly. Sometimes in the AP test, they'll give you a problem, and the bases of the rectangles are all different, so you have to calculate them separately. But we're going to assume all these h's are the same. So this is our height. So we have 1/2 times the height is h over 2. And then the bases, what's the length of the 2 bases on the first one right here? Yeah, so it's going to be y1 plus y2. The next trapezoid is going to be h over 2, and then y2 plus y3, plus h over 2, y3 plus y4, plus h over 2, y4 plus y5. So if we've got 4 trapezoids, this is 1, that's 2, that's 3, and that's 4. Does that make sense? Is that clear? Yeah?
Yes.
Thank you. Okay. So now what I'm going to do is I'm going to do something a little fancy. It's not that fancy, but it's a little fancy. I'm going to factor out an h over 2. And then what we have is we've got a y1. And then how many y2s do we have? 2 of them. So we'll write 2y2. How many y3s do we have? 2 of them, so that's 2y3, 2y4, plus 1y5. It's clever, right? And then, now what I'm going to do is I'm going to put a 1/2 here, and then with the h, I'm going to split up my y1s, or my y2s, y3s, and y4s. So I'm going to say this is going to be h times y1 plus y2 plus y3 plus y4 plus h times y5 plus y4 plus y3 plus y2. And now I want you guys to notice what's going on, because h is the, your base, and y1, y2, y3, or y4 are the heights of which endpoints? Those are the heights of my left endpoints, right? y1, y2, y3, y4. Where y5 through y2 is the height of my right endpoints. So what is this, really?
LRAM.
That's LRAM. And this over here is RRAM. So what I'm doing is, what I did with some clever algebra manipulation was to demonstrate that the trapezoid method is the average of LRAM. Wait, is R, yeah. Left, yeah, okay. Right, yeah. And over to. I was trying to find out if I was being repetitive or not. Okay, so your calculator program has LRAM, RRAM, and midpoint. It doesn't have trapezoid method, but if you can figure out LRAM with your calculator program and RRAM with your calculator program, hopefully you're adept enough with your calculator that you can find the trapezoid method. Does that make sense? And it's just kind of interesting to notice that the trapezoid is just the average of your left and right Riemann sums. Right? That's good. That's it.